the next thing that we're going to be talking about today is continuing our discussion about C++ and some of the sort of intricacies, details, things that are really useful to know about as you're writing your Rosetta code, and how you can really take advantage of the language to do some really interesting and cool things. So just a quick overview of what we'll be talking about in today's lecture. First, we'll talk about the const keyword. You might have seen this over the past couple of days, but we'll be going into detail about how you can use const, how to use const correctly, and being consistent about it in your code. A little bit more about functions in C++ and constructors, how you can use different function names to overload and give functions different features, static methods, and then we'll also talk a little bit about design patterns and how you can use these in your object-oriented code to achieve more efficient code. So first, I want to talk about const, probably in a lot of detail. And when I think about const, the first thing I think about is that when I'm programming, I always think about a monkey is trying to kill all of my code. Somebody is out there to give the function arguments the most nasty, unreasonable things whatsoever, and to misuse things as much as it possibly can. So the question is, how can I use C++ to solve this problem? How do I know that another developer is not going to misuse my function and to maybe modify data in a class that I wouldn't necessarily want to be modified, so you don't get some effect like this where you have a wall and you don't want somebody drawing all over it. You want to really make that guarantee that if you have data or if you're working with a method, things aren't being changed that you don't want to. So in C++, we have this reserved keyword called const. Const indicates that something can't be changed. In other languages, or depending on what you're using, this is the concept of immutability, that variables will have a state and they won't change, or you'll use things in a context that are immutable. And the const keyword can be applied in different areas of the code. It can be applied to return values of instance methods, variables. It can be applied to the instance methods themselves, and also to different function parameters that you might pass. And const is really, really powerful in C++. You get a lot of benefit out of it, especially if it's used correctly. The first benefit is it provides this utility of immutability. So for example, in the confirmation class that we learned about yesterday, confirmation hands out const references to residues. So think about it, if you construct a pose, do you really want your residues changing in certain contexts? So by applying the const keyword, confirmation can safely hand out references to these residues without worrying about someone else is going to go change them and change the data in confirmation without sort of letting you know about it. You get more data integrity here. You know that the data that you're passing out is going to stay the same if you want to. And the compiler will guarantee this, that we'll see in a couple of minutes. And then another benefit of const is speed. If you pass an argument to a function, and it's non-const, in a reference, you'll make a copy of it. If you can just work in const context, you don't have to do that, and you get additional speed benefits. So how do you use const? The const keyword can either precede or follow the type. So you can see these two lines are equivalent. If you say const int 5 equals 5 or int const 5 equals 5, it means the same thing. The compiler will interpret it as the same thing. But in Rosetta, we prefer that you put const after the type. So the second one is the acceptable one according to the coding convention. And also, if you're a little bit more familiar with C++, we prefer this to using macros to define constants. It's much better to use the keyword, and that's also part of the coding conventions. So how do you use const? So for a variable, as we just talked about, you'd want to use the second line. So you'd want to declare const after int. And when you do this, it's a good way to think about const is what you're telling the compiler and what sort of guarantee you're asking your program to make for you. So if you have a const in, you're saying that once I initialize this variable, it cannot change, and nobody else can change it. So let's look at an example we should have. So here's just a program of some code. These examples are from Brian Weitzner's lecture. So you have int a, int main, and then you have the variables. So what do you think this prints out? It's a little early. Yeah? Yeah. Yep, that's right. So yeah, there's no const here. Nothing's going to complain or cry. So you don't have any issues. You'll just print 6. But if I apply const, what do you think happens now? Anyone? Yep. So because we declared const, we told the compiler, please do not change this variable. And the compiler enforced it. So you'll see const C++ error, read-only variable is not assignable. So read-only meaning immutable or const. So another place that you can apply const is to function parameters. So you can declare arguments going into a function as const. And what this tells you is that you're asking the compiler to guarantee that this method, so my awesome function, will not change this reference. So you guys might have seen in one of the homeworks, the calculator homework, when you passed methods, when you passed arguments by reference, you were allowed to change them, and that was the way that you assigned your variables. But in this case, you're saying, please do not change it. That's not allowed. So here's an example of using a const argument or non-const argument. So what happens in this code? Their typo? Right. Yeah, 5 down there should call A. Sorry about that. It's a typo. Anyone want to take a guess? You want to speak up? No. Think about it again. So what's the first line printing? So what's the first line printing? Yeah. Great. So yeah, there's no const issues here. So it would print out 506. And then we can take the same example and apply const. There's no typo in this one. So what do you think happens here? Anyone want to guess? So think about what we just talked about, like what happens if you apply const to a variable, and what happens if you pass a const variable into an existing method. Yeah? Right. So the compiler error that you would get is that there's actually the function signature changes. So we'll talk about the function signature later. But because you don't have const here, where it says crazy func input, it's as if you're applying the variable to a function of a different type. So the compiler says you're passing a variable that's not the same variable that I'm asking for. So yeah, you would get a compiler error. And then this is another example. So can anyone tell me what happens here? Take a couple of seconds to look through it. Are there any type mismatches here? Right. Yeah. Yeah. So you'd also get an error here because even though you've declared const in both your variable and your method signature, you're still trying to change it. So you're still breaking that contract where you said, I'm not going to modify the value of my variable in this method, but you're doing it anyway. So the compiler would also complain saying, read-only variable is not assignable. Yeah, and then this is just sort of one more example of where you can sort of apply const. So can anybody tell me what this prints? And then what else? Missing something. Oh yeah, sorry. This is another typo. These two should match up. So maybe I do something crazy here. It's the same method. Mm-hmm. 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 And then, yep. So I'll show you in a second. But think about the benefit of having const here. If you have a loop and you're guaranteeing that you're not going to change the end of your loop, think about what crazy things could happen if somebody decides to start changing this value on you while you're running your loop. Things would break. So const is a really good, this is a good example of using const here. So yeah, this would be the function output. You have 5, 0, 1, 2, 3, 4, 5, and then print the rest of the line. So another place in which you can apply the const keyword is in return values. So you guys might have seen a lot of classes have getters and setters. So things where you can set a new value of a private member in a function and then access that later. But the problem is that data might be private for a reason. It doesn't want other people on the outside modifying it. So what you can do is use a const return value to provide read-only access to the data member from that method. And the contract that you're sort of instantiating here is saying that this return type can't be modified. Only the class can still modify what's in that type. And it's really important to note, it's really easy to overuse this type of const. It's important to think about in what context you'd want to apply const, and you want to make that guarantee. And it's only usually appropriate when you're returning a reference to private data. So this is an example of how you could use that. If you have my class foo and you're returning the variable bar, you can apply const and say that that variable can't be changed once it's, oh, well, in this case, it's not useful because you're not returning a reference. So it wouldn't be changed anyway. You'd just be returning a copy. Sorry. And then also, you can apply const to methods, so methods of a class. This is particularly useful also when you're trying to provide read-only access to a class's data member, but you're also trying to guarantee that that member is const and using in a const-only or immutable context. So there are a couple of things that you would apply when you're using const methods. The first is that non-const methods can't be called from const. So if you have a const, think about it, if you're working in like a context that is immutable, if you're calling non-immutable methods, you sort of have a mismatch. You're saying I can change things and I can't. You want to be consistent. Also, the class data members are const within instance methods that are marked const, so you can't use non-const members in a const method. Then also, if a member is an object, only methods marked const can be called on it. So once again, you need to be consistent. If you're calling const methods, you need to be working with other const methods and variables. So yeah, this is an example of how you would declare a const instant method. If you have getString, you can call it const, and that's returning a const reference. So you're being consistent. You're declaring your your return type const and your method const. So here's an example. You have a class, and then you're showing your string. You have a getter and setter here. And then you have a main function that's saying, I'm going to create a new class, and then set a value here. So yeah, you can see because because you have a string that's not const, when you pass it, it's not consistent. So yeah, const is sort of a little bit of a tricky thing to get right. You need to be really careful when you're applying the keyword and you're working through. Always ask yourself when you're writing a class, should this be const? Should this method to be const? Do I want it to change? And const correctness is really important. It's part of the coding conventions. It helps us to write better code that people understand like what it might be used for or why they might want to call those methods. So the next thing that we're going to talk about is a little bit more about C++ functions. So what are the different parts of it? You've been calling these at least over the past 2 days. So there are parts of it to be aware of. You can break it down. So you have the return type. So this is a method in confirmation that we talked about that returns a residue. So return type, residue const, the method name, the type of the argument that you're passing, whether that argument type is const, and then whether the method is const. And when we refer to the method signature, we're saying this is comprised of the method name, the argument type, the argument, whether the argument is const, and whether the method arguments are const. So remember, it's not just about, when you're using methods, it's not just about the argument type, but whether those argument types are const or not. It will make a difference whether you can apply a function to a particular parameter or not. And yeah, so now we can start talking about some of the consequences of when you're trying to use C++ functions and whether they have different method names. So the first problem that sometimes you want to address is you have a function name. It's a really good name, but you need two versions of that function that do two separate things. So the example I thought about this is if you have like a class smoothie that just represents the drink, and then you have a class blender that's responsible for making these smoothie objects. I want to have the same method name make smoothie, but technically you could have like lots of ingredient combinations that you would want to pass to your method. So one concept in C++ that we have to solve this is overloaded methods. This is the case where you can have the same function name, but you can have different signature elements. So different, in this case, you would want to return the same type, but you'd want to pass different arguments to the function. This is a really cool feature of C++ and a couple of other languages. It's useful, especially when you're designing code. And you get benefits. You get benefits that when you have a good function signature, you get to keep using, or when you have a good function name, you can keep using that function name, but your code will still compile, especially when you can't change the name of the function. There are cases in which it's useful to preserve the same method name. So just sort of going back to the example, if you have class blender, what this would allow you to do is actually define two different methods. So like for first method, you can define make smoothie, number of bananas, number of strawberries, and then alternatively, if you just want strawberries, you can have one argument to your method. So another thing to know about when you're using methods in C++ is virtual methods. On Monday, Jason talked about inheritance and how you can define a base class and then extend that. So a lot of times when you're trying to implement methods defined in the base class, which are your virtual methods, you need to be really careful that your function signature in your derived class matches exactly your base class. So for example, if you have a class dog, And you define 3 methods, get breed, get color, and get age. But get breed is the one that you would want to override. Can everyone tell me what the signature, if it's properly implemented, of get breed would be? Yeah? Can you repeat that? Right, right. So you'd use the same method signature. So, but you don't need to write virtual in your derived class. You ought to? Okay. Okay, cool. So even though it's not written here, the coding conventions say that you should include virtual in your derived class, as well as if it's defined in the base class. So another sort of feature of C++ is that not only can you overload methods, but you can overload constructors to a class. This becomes really useful if you have different ways in which you might want to construct an instance of a class. So you can define different constructors. The default constructor takes no arguments. There's a copy constructor. We'll talk about these more later this week. But what a copy constructor will do, it's generated by the compiler if it's not explicitly defined, but it'll allow you to create a copy of that class from an existing instance of that class. And then you can create other constructors too. It's really useful if you want to make custom constructions of your different methods. So an example here, if you just have my class, the first constructor right underneath public, that's your default constructor because it takes no method, it takes no arguments. The copy constructor is the second one listed here. It's constructing the new class from a const instance of the old class. And what you should note is this sort of cool feature, because you're taking the class, you're technically inside the class. So you can access its private members directly instead of having to use getters and setters. And then finally, you can have some custom constructors. So in this case, this class has a private member string s, and you can use a constructor here to set that particular variable at construction. And then sort of the last sort of method feature that we're going to talk about today is static methods. So static methods are methods that you define in a class that don't require an instance of the class to be invoked. So this means you don't necessarily have to construct it. It doesn't have to access non-static data. It can access the private members of the class, even though it's not constructed. But it's really important when you're writing classes to avoid non-const static data in your classes, is because it's not thread safe. So basically what would happen is if you define static data, it's non-const and other people can access it and change it. You don't necessarily know when it's being changed or who's changing it. So it causes some serious data integrity issues that you might want to avoid. And so you might have seen static methods a little bit this week. In the task factory, the method createPackerTask is a static method. And you can define it using the static keyword here. So the last thing that I'm going to talk about today is design patterns. On Monday, Jason talked about object-oriented programming and different ways to sort of break up maybe a particular problem by using class structure. But it turns out that there's been a lot of work to figure out certain patterns that might be useful if you have a particular patterns. So design patterns are sort of like a set of solutions to some known problems when you're working in object-oriented programming. They're really useful. They provide this common language for people to communicate. If you say, hey, I used this pattern to solve this problem, people might know more of what you're talking about. You can find them all over Rosetta, even without looking for them. Once you know about them, you might start recognizing different patterns that you've learned about this week. And then the biggest advice that I've ever been given when designing with patterns is don't design it to fit the pattern. Usually knowing the pattern will help you when you're designing code, but you don't necessarily have to say, oh, I need to use this pattern to make this class work. It usually just sort of fits as a solution to what you might be working with. So the first pattern, so what's really interesting about patterns is that usually problems motivate patterns. So the first pattern in Rosetta, or the first issue in Rosetta that a pattern might solve is the job distributor. So we'll talk about job distributor a little bit later this week, but what it's responsible for is sort of managing inputs and outputs when you're working with different protocols. But the issue is you only really want one guy in charge of saying, where are my inputs going, where are my outputs going? You don't want multiple people sort of managing this problem. You only want one instance of a class that would be responsible for this task. So the pattern that would fit this is the Singleton pattern. Singleton pattern is what guarantees if you have a class, you'll only have one instance. And what's characteristic is this Singleton getInstance method. That means that if the class is already constructed, it will return this existing method. And because you're using static data, you get this guarantee. To guarantee this, also the constructor becomes private. So you can only call that getInstance method. That further ensures that you're never creating duplicate instances of that class. And yeah, so you can only return a single instance when you're working with this pattern. And Singleton occurs in different places in the Rosetta code. I just talked about it occurs in the job distributor, but it also occurs in scoring manager, the mover factory, and the filter factory. And you can definitely find it other places as well. And then the second problem that you might want to maybe motivate with a design pattern is how to initialize Rosetta. So I don't know if you guys might have thought about, but when you're developing your pilot apps, we told you to include this devel init line at the top, and that would initialize all of these sort of necessary components in Rosetta. But this is not necessarily a trivial problem. There are lots of things that have to get initialized, and the order matters in which, so things like the option system, the movers, different elements of the resource manager, random number generators, and so forth. So one pattern that you might use to solve this particular problem is a factory design pattern. Sorry, it should not say abstract. It is abstract. Okay, that's fine. The factory design pattern is a pattern that will allow you to create lots of different objects. And usually they use little or no private data. They're just sort of linked to a series of other classes that will help them to create different objects. They're used if you need to initialize objects in a custom creation series, and these are also used in various places in Rosetta. So one example I'm sure uses mover factory, filter factory, task operation factory. Scoring manager is, I guess, also sort of factory, and then what we just talked about, devel init. So yeah, that's about it. Does anyone have any questions? No? Okay. The what? Yeah. So the question was to explain what the Singleton pattern is. So the purpose of the Singleton pattern is to guarantee that you only have one instance of a class. So I guess I'll try to use the same example for the job distributor. So in Rosetta, when you say, here's a PDB file or here's a set of inputs, you need sort of a single person in charge in like all of the Rosetta system to say where that input is going to go. If you had multiple instances of a class who are sort of making those decisions, you can get conflicts, you can get kind of a mess. So what you want to do is guarantee that you only have one sort of person or class in charge of those responsibilities. So that's what Singleton is guaranteeing. By making the constructor of the class private and calling just getInstance, it'll guarantee that you're always returning a single instance of that class. Does that kind of make sense? Yeah, so the Singleton class, so the characteristic parts of the class design is that your constructor is private, so people can't just call the constructor. And you have a getInstance method, which guarantees that if the class is already constructed, you're only returning that same instance. So you can't create a singleton twice. You just have one instance of that class.
And getInstance, you could also say is static method. So
Right.
It's almost as if static methods are kind of separated from actual instances of the class. You don't have to make a singleton to call the getInstance function on that. You just say getInstance when you look at a class name. As opposed to calling a function on a variable.
Right.
Maybe you could write up an example of how you would the job distribution.
For singleton?
Yeah, just what the function signature will do. Say you're writing an application, you're going to use the job distribution.
Yeah.
How do you get that job distribution?
Yeah, so a lot of times in the main of an application in Rosetta, so you have, usually Rosetta will kick off a class called a mover, which we'll talk about later. So you just have mover. So the job distributor is not like a regular class where you just call the constructor. You call job distributor. getInstance. So before I go any further, notice you're not constructing the job distributor class. You're just calling a static method, which doesn't require that class to be constructed. And then point to a method called go, which will take your mover. So because you're calling getInstance, which guarantees a single instance, you can ensure that only one job distributor is sort of taking care of all of these jobs in Rosetta. You don't have multiple passing through different jobs. You'd have like a lot of conflicts if that were to happen.